Hi everyone, my name is Seokhyeon Bae, and today I'll be presenting our work on reliable federated TinyML deployment for IoT security, which I worked on with unsoo Park under Professor Suman Saha. So let me start with the motivation. As IoT devices, especially microcontrollers like ESP32, are becoming more widespread, they're also becoming more exposed to cyber threats. The problem is that most intrusion detection systems today rely on neural networks that are simply too heavy and too expensive to run on these small devices. So the question we asked was, how can you build something that is both robust and actually deployable on constrained hardware? To address this, we designed a federated TinyML pipeline. First, we focused on training stability. Instead of using fixed learning rate, we use the cosine learning rate that is server coordinated with the focal loss to handle class imbalance. And this alone had a major impact. Our recall improved from 46.7% to 98.85%. And then we tackled the deployment constraint, which is model size and latency. So we applied a structured compression pipeline for batch normalization to distillation, pruning, and quantization. With this pipeline, we're able to make the model about 12 times smaller and roughly 74% faster. And average performance actually improved with this setting. And the most interesting part of our work comes from analyzing QAT with the quantization-aware training. So intuitively, you might expect QAT to always help, especially under compression that involves post-training quantization. So to check if QAT enhances the model performance universally, we tested 48 different configurations with different techniques. What we found is actually much more surprising. So this is a result graph for 38 different configurations. We actually saw that the no QAT line always outperforms the QAT lines, except for just one case when we use the progressive distillation with heavy pruning. So our conclusion is pretty clear. QAT is not universally beneficial. It only works when you have the right combination. In our case, progressive distillation, heavy pruning, and PTQ. Also, outside of this setup, you're actually better off not using QAT at all. So overall, our work shows that in TinyML system, performance is not just about individual techniques, but about the interaction between them under strict constraints. Thank you.